So what really makes something a poison? It's not so much about where it comes from, but all about what it does to you. In this explainer, we're going to classify the world's deadliest substances not by their source, but by their method of attack. It's a whole different way of looking at them.
So let me ask you this. What's the real difference between a medicine that can save your life and a poison that can end it? Well, the answer is actually pretty simple. It's the dose. I mean, think about it. A super tiny amount of botulinum toxin, you probably know it as Botox, can smooth out wrinkles. But just a little bit more of that exact same substance is one of the deadliest things on the planet. And that fine line, that razor's edge, is what the entire science of toxicology is all about.
All right, so here's our game plan. We're going to start with the poisons that just physically obliterate your tissues. Then we'll get into the sneaky ones that hack your nervous system. From there, it's on to the heart stoppers and the suffocators before we wrap things up with some of the dangers that, well, might just be hiding in plain sight around you every day.
Okay, let's start by laying down some groundwork. Before we get into all the grisly details, we really need to understand the science of toxicology itself. I mean, how do you even begin to make sense of a world that's just full of potentially harmful stuff?
At its core, toxicology is pretty much the science of how things can hurt us. But with millions of chemical compounds out there, where would you even begin? You absolutely need a system. So toxicologists decided the most useful way to group these things was by how they attack the body. And that's the framework we're going to be using.
So our first category is all about brute force. We call them the destroyers. These are the corrosives and irritants. They don't use stealth. There's no subtlety here. They cause immediate, raw, physical damage to any tissue they touch.
Now, the destroyers come in two main flavors. First, you've got your corrosives. Think of things like strong acids or drain cleaner. They literally dissolve tissue on contact. Then you have the irritants. Now, they're a bit more subtle. They don't dissolve you, but what they do is trigger such a massive inflammatory response that your own body starts to damage itself.
And the range of these irritants is just staggering. They can be simple elements like chlorine or those infamous heavy metals like arsenic and mercury. But they also come from the natural world, from the ricin inside a castor bean to the crazy complex cocktail of proteins you'd find in snake venom. The source is totally different, but the effect, that severe, damaging inflammation, is the same.
Okay, so we've gone from brute force to sabotage. Our next category is what I like to call the system hackers, or neurotoxins. These poisons don't destroy tissue. Instead, they hijack the body's most critical network, the nervous system.
You see, with neurotoxins, it is all about location, location, location. Their effect completely depends on what part of the system they target. Some go right for the command center, the brain. Others disrupt the main data highway, which is the spinal cord. And then there's a third group that attacks the peripheral nerves, basically cutting off communication to the rest of the body.
Now, when neurotoxins target the brain, the effects are incredibly specific. Some, like opioids, are depressants that make you sleepy. Others, well, they do the exact opposite. Stimulants like caffeine or amphetamines put the brain into overdrive. And then you've got substances like alcohol or cocaine that hijack the brain's reward and perception systems, causing intoxication or delusion. Each one exploits a totally different neural pathway.
The attack can also be much more focused. Strychnine, for instance, blocks the off signals in the spinal cord, and that leads to these violent, uncontrollable convulsions. And then you have poisons that go after the peripheral nerves. Hemlock, which was famously used to execute Socrates, works by stopping nerve signals from ever reaching the muscles, and that causes this slow, creeping paralysis.
Our fourth category zeroes in on the body's engine, the heart. These are the heart stoppers, or cardiotoxins. And they're a really specialized group of poisons that target the cardiovascular system directly.
And you can find these in some surprisingly common places. Digitalis, which comes from the beautiful foxglove plant, can cause a fatal heart rhythm. But, and this is the fascinating part, in tiny, super-controlled doses, it's also a life-saving heart medication. It's a perfect example of that fine line we talked about right at the beginning. Other cardiotoxins are a bit more straightforwardly dangerous, like the oleandrin in the common garden oleander, or even nicotine from tobacco.
All right, next up, the suffocators. The goal of these poisons, which we call asphyxiants, is really simple and terrifying. They kill by preventing the body from getting or even using the oxygen it desperately needs to survive.
So, asphyxiants have three main strategies in their playbook. The first is just simple displacement. Gases like nitrogen or carbon dioxide fill up a space and physically push all the breathable oxygen out. The second one is way more insidious. Chemical asphyxiants, like carbon monoxide, they let you breathe the oxygen in, but they stop your red blood cells from actually delivering it. And the third is just a direct assault.
Irritant gases like chlorine completely destroy your lung tissue, making it impossible to absorb oxygen at all. 3 different methods, 1 fatal result.
Okay, I know, a lot of this sounds super exotic. Strychnine, hemlock, cyanide. It's the kind of stuff you read about in spy novels. But the world of poisons isn't just historical or some abstract concept. It is so much closer to home than you might think.
And that brings us to our final section, everyday dangers. This is where we uncover some of the toxic substances that you might encounter without even realizing it.
This is really where toxicology gets personal. I mean, we are surrounded by substances that are designed to be toxic. Things like insecticides on our food or rodenticides on our walls. Even common household products like mosquito sprays that have pyrethroids in them are technically neurotoxins. And of course, the bacteria that cause food poisoning, they're producing their own biological poisons. Understanding their risk is just a crucial part of navigating the modern world.
So from the brute force destroyers to the subtle system hackers, we've seen that poison isn't just one thing. It's this vast library of substances, each with a very specific way of attacking the body. The real key takeaway here is having this new framework for understanding risk. So the next time you see a cleaning product, or a common garden plant, or even a medicine, how are you going to think about it differently? Thanks for tuning in.